Assalamualaikum and hi everyone, this is Dr. Shazira. In this video, we are going to be discussing the Gauss elimination method. Consider this problem. Okay, we have a system of 3 equations and 3 unknowns here. Okay, so the first one show that there exists a unit solution for this system, and then B, perform Gauss elimination method to solve the systems. In other words, find x1, x2 and x3. Okay, do the calculation using 3 significant figures. A system AX equals B is said to have a unique solution if we satisfy 2 conditions. Okay, the first one, A is a square matrix, okay, n by n dimension, and determinant of A is not equal to 0. So in this problem, okay, A is 3 by 3 matrix, and determinant of A for this case, for this example, is equals 13.641. Okay, and this is obviously not 0. Okay, you can use your calculator to get the determinant of A. So we can see here we are satisfied the 2 conditions. So we can say that, the system has a unit solution. So therefore, this system in this example, okay, has a unique solution. Or you can say there is a unique solution for this system. Okay, that's E. Okay. Perform Gauss elimination method to solve the system. Okay, so we have a matrix. So write down your system in the form of augmented matrix. Okay, so this is our system in the form of augmented matrix, and now we want to use the elementary row operation to transform this augmented matrix here to be in the form of Ux equals F here. So this is our aim. Okay, so from the matrix A at the left here, we want to have the upper triangular matrix here. So you can see at the first row here, okay, as long as it is non-zero elements at the first row, then it should be okay. So we can see that the first row here is okay. Okay, so it means that we can just rewrite the first row. Okay, so now the first element that we wish to be 0 is at this location, okay, which correspond to this 1.48 here. So we want to think of what is the correct operation so that 1.48 here, okay, is transformed to 0. Okay, so the formula is like this. So 1.48, the element that we wish to be 0 is at row number 2. So we write down R2 here at the left, okay, and then we put plus R2 here. So this is the fixed formula, okay, that you can follow, okay, so that every time you want to have the operation, you can use this pattern. Okay, you can use this format. So R2, the element we wish to be 0, so you put at the left hand side here, and at the right hand side you put R2 plus R2, positive R2. And then we want to relate with the row that is already okay, which is row number 1. So we put here R1. Okay, but if we just have R1 plus R2, 1.48 here is not yet 0, because if we have 2.51, which is at row number 1, and then we plus with the R2, it is not 0. Okay, so we need to think of what is the correct coefficient for the R1, okay, so that when we perform the operation, 1.48 will be 0. Okay, so what do the idea is, R2 at the left should be 0, okay, somehow later, okay, when we perform the right operation, it should be 0. And then we want to know what is the coefficient here, okay, so that when we multiply with the R1, okay, which is 2.51, and then we plus with the R2, which is 1.48, okay, so what is the correct coefficient here? Okay, so in other words, we can see that what we want to have at that part is basically negative 1.48. Okay, so that when we add with 1.48, then the value will be 0. Okay, so how or what is the correct term that should be here, so that when you multiply with the 2.51, the value will be negative 1.48. Okay, so we can see that somehow, okay, we need to cancel out 2.51. So somehow we should have the fraction is which at the bottom we should have 2.51, so that later we can cancel out with that value. So of course at the top we should have negative 1.48. Okay, and then you can check. Okay, so we will have negative 1.48, and then we plus with a positive, so the value will be 0. So you can see the coefficient here, okay, should be in the box here. Okay, and this term here is actually comes from, okay, so this is what you should have. Okay, so at the top, okay, so of course we need to have the fraction here somehow. Okay, I just okay, we have the fraction. So at the top, it should be the element that we wish to be 0. So at the first place here, so we want to have 1.48. Oh, where is okay. Okay, the element that we wish to be 0, okay, 1.48 over the element that we are relating to, which is 2.51. And then we need to think of whether, we should have the negative or positive here. Okay, so since this R2 here, this 1.48 here is positive, so we need to have, of course, we need to have the negative value. Okay, so that is the correct operation to make sure that 1.48 will be 0. Okay, so we perform that operation, okay, to the rest of the elements in row number 2. Okay, so you can check or you can use your calculator. Again, negative 1.48 over 2.51. Okay, so you multiply with the 2.51 here, you add with 1.48. So the value at the second row will be 0, of course. Okay, but this element here, 0.93, okay, negative 1.3 and negative 0.75 also need to be performed with these operation as well, okay, because they are in the same row with 1.48. Okay, so it means that for 0.93 here, so you will do negative, okay, this one here multiply with the 1.48 plus with the 0.93. Okay, so that the value that you should have is supposed to be 0.0573. And for this example, remember the question asks you to use 3 significant figures. Okay, so write the value accordingly, okay, in 3 significant figure here. So the same thing for negative 1.30 here. So you need to do, this one here, multiply with the 4.53, and then you add up with a negative 1.30. Okay, so the value here should be negative 3.97. And similarly for this guy here, so you also perform the same operation. Okay, so the R1, you will replace the R1 with 5.56 and R2 with a negative 0.75. So you are supposed to get negative 4.03. Okay, so that is the second rule. Now, okay, we are okay with this one. Okay, now we want to proceed with the second guy here, which correspond to the 2.68. Okay, so again, we're using the same format here. So 2.68 is at row number 3. So you put R3 at the left and you put the positive R3 at the right. And you are relating with the row number 1, R1. And now think of what is the correct coefficient that should be here. So again, you can see from the previous operation, so you have a fraction over there. So at the top, it should be the element that you wish to be 0. So in this case, you want to have 2.68 to be 0 over the element that you are relating to is the element at row number 1, which is still 2.51 here. Okay, similar, the same as in the first operation. And then we should have negative here. Okay, if this guy here is negative, then you should have positive sign over there. Okay, all right, so now with that operation, okay, we can make sure that 2.68 will be 0 somehow. Okay, because you can see clearly. Okay, you are going to replace this with 2.51, okay, which can be cancelled out with that guy. Then here you will replace with a 2.68. Okay, so similarly, okay, the rest of the sibling here and the row number 3 here should be performed, okay, with the same operation. Okay, so 3.04 here. Okay, so you apply the same operation. Okay, so you are supposed to get 1.46 here, and then negative 6.32, then negative 7.78. Okay, again, make sure you use the 3 significant figure. Okay, now we are okay with that guy. Now move to the second column. So now our concern is that guy which correspond to this one now. Okay, 1.46. All right, so 1.46 is at row number 3. So you put R3 at the left, you put positive R3 at the right. And now you are at the second stage. Okay. Let us have a line over here to differentiate, between the first stage and the second stage. You are now at the second stage when you are actually, moving to the second column. Okay, so now you are relating to row number 2 because row number 2 is already okay. So you are relating with row number 2. You are not relating to row number 1 anymore. Okay, because if you relate with row number 1, okay, we are afraid that you are going to change this guy here from 0 and suddenly it will not be 0. Okay, if you are relating to 2.51. Okay, because obviously you will if you put the R1 here, so later you will multiply with a 2.51. Okay, and then you plus with a 0. So this guy here will turn to non-zero value. So we don't want to do that. So that's why we relate with R2 instead of R1. Okay. So now, okay, put the fraction here. Okay, so again, that fraction comes from, okay, so it comes from the element that we wish to be 0, which is 1.48 here, okay, at the top, over the element that we are relating to, which is at row number 2, which is this guy here. Okay, so we put in the fraction, we have 1.46 over 0.0573, and we need to think it should be negative or positive. Okay, so since the element that we wish to be 0 is positive, okay, so we need to have the negative sign here. That's it. Okay, and then we have a new matrix. Okay, write down the first row and the second row. You can just rewrite, because the first two rows are already okay. All right, so this 0 here, okay, if we perform the operation, so this guy here, if we perform that operation, so of course we will get 0, because the R2 here will be this guy, okay, 0. So you plus with the R3, which is that guy. Okay, so you come out with a 0 as well here. And then for 1.46, of course, we should have 0, because at the first place, that is our intention. Okay, so the operation that we have here is to make sure that 1.46, okay, is turn out to be 0. And then this guy here, okay, negative 6.32. So we apply that operation. It means that you replace R2 with negative 3.97. Okay, and then R3 here is negative 6.32. Okay, so we should have 94.8. And for this guy, okay, perform that operation, and we should have 94.9 in three significant figures. Okay, so now you can see that we already have the upper triangular matrix. Okay, so we are now have the ux equals f. Okay, so we can stop doing the ERO, so we can proceed with the next process. Okay, so remember our intention at the first place is to have the solution. What is the value of x1? What is the value of x2? What is the value of x3? All right, so from ux equals f here, we can see that, from the third row, okay, from the third row, so we know that 94.8 x3 is equals 94.9, okay, at the right hand side. So obviously, you can get your x3. Okay, and then when you get your x3, you move to the second row where you have 0.0573 x2 minus 3.97 x3 equals negative 4.03. Okay, so since from that equation you get your x3, so of course you can substitute in the second equation here, and then you can get your x2. Okay, and then after that you go to the first row where you have 2.51 x1 plus 1.48 x2 plus 4.53 x3 equals 5.56, and solve accordingly for the value of x1. Okay, that is the manual calculation. So the solution for those simultaneous equation that you can see here, okay, can be obtained by the calculator. So you can use the calculator to get the value. You can check out my video on solve three simultaneous equation, okay, using the class with calculator. But for this example, I just put somewhere here by calculator. By calculator, we have x1 equals 0.983, x2 equals negative 0.974, and then x3 equals 1.00. So all of the values should be in three significant figures. All right. So that's the process of Gauss elimination. Okay, so I hope you can understand, okay, how to come up with the operation, okay, to transform your augmented matrix to be, in the form of upper triangular matrix here. But anyway, the operation here is actually not unique. Okay, you can think of any other operation, as long as you can transform this guy, and this guy here to be 0. Okay, but what you can see here, what I have shown you here, is actually the fixed format. Okay, the one fixed format, okay, for the operation. Okay, so given to you any augmented matrix, so you can use this kind of format, okay, the operation format of the operation, to make sure elements, this one here, this one, and this one, okay, are all 0. Okay, but again, if you insist to have your own operation, you can proceed, but towards the end, you are actually should be getting the same answer. Alright, so that's all for the Gauss elimination. So see you in the next video. Bye bye. Assalamualaikum.